I don't know how well this is going to pick up, but this is a laser pointer just being diffracted by strands of my hair. Now if I try not to move too much, let's see if I can find a good position. It almost stabilizes, but you see the clear you know, interference pattern, but obviously it's not because of some Heisenberg principle. It's not because we know where the photons are. You know, they're just, you know, being diffracted by pieces of a hair. And obviously hair is the right size to maximize this effect on light. It would seem probable that the you know, that the effect, each bar, each one of those lines represents a single hair that's creating that effect. Kind of in a lensing way, I would suppose, or something like that. So anyway, just curious. So, draft physics video and such. I probably should turn some light on now. Maybe that one. Anyway, yeah, that was me. So I thought I'd play some of this MIT, you know, Walter Lewin guy. So this is a single slit experiment where he just basically, you know, mechanically. Oh, I should turn that pointer off. Don't want to kill the batteries and such. You know, where yeah, single slit. Mechanically, you know, just you know, he can very carefully narrow the gap, and there's this point where the gap, you know, creates this pattern, and you know, to some extent, or the light is more affected, it seems, and it doesn't seem to be doing what you would expect, which is the same effect. So anyway, here's the. So this would be the classic explanation that, okay, the slit's open, one slit, and you fire the light through and you just get a blob. But the truth is that if it's as narrow a slit as in the two-slit experiment, you don't get a blob. So as he narrows the slit to the size that's traditionally in the two-slit experiment, clearly one slit starts creating an interference pattern. Now this interference has to be not because the photon traveled through both slits, but somehow the photon's interfering with itself without having a separate wave. Right? It's the only way it could be happening, correct? So that doesn't make much sense. But it just illustrates that, you know, this gets kind of convoluted because traditionally the experiment is explained that this is what the result you get, and this isn't the result you get with one slit. So let's play some of this.
Yeah, it's all the way open, and I'm going to close the slit now slowly.
Unfortunately, this comes out quite different in the video. There's a big white spot.
And if you look closely,
but maybe it's seeing what I can't see.
You will see that the... Let me also get my...
So the idea is to watch the sides getting cut off. And the point I would argue, I guess, is to say that which way this light gets reflected, you know, off the slit. So the slits here, is the light going around it, or is the light going that way, bouncing off? And I'm tending to believe that it gets deflected that way more than that way. That's what I'm tending to believe.
Red laser, and I can put something else. You will see that...
Now see what I'm seeing in the camera, there's a very white section here in the middle. And when I look at it, all I see is green. And a little tiny, where you see blue, at least I'm seeing blue in the camera, is this little tiny highlight. And I can barely tell, I can barely see that ring. So this is part of the problem with this experiment too, is that these sources of light are not consistent sources. You know, they're not only diffused, but obviously there's already built into this source a ring. So it already has an intensity ring in it, which, you know, kind of makes this whole thing a little bit not too pure as an experiment.
Light will get squeezed in the horizontal direction. You can see already that the left side has a very sharp vertical cutoff, and the right side also. It's getting narrower, getting narrower, getting narrower, but I know...
Okay, so that was kind of a big jump there. So now we're seeing a little bit of this cutoff, and we're also seeing the formation of some weak spots in the pattern here. So we've already got like 3 lines, at least maybe 4. You can see 1, 2, 3, 4 lines being created. I don't know what the best distance is for this camera. Let me take the lens off for the purpose of this and see if that's any better. Yeah, I don't think it really is. Well, we'll see how it goes. But so you can see a little bit. I can see more in the camera. It's funny, I can't see it in the video at all, but there is a little blob right here. So it's already spreading.
Nearly a tenth of a millimeter yet. Getting clearly narrower. You see it's getting narrower.
See, I can see clear lines here, and you can't really see them in the camera, but I can see clear lines. 1, 2, 3, 4, 5, 6, 7 lines on just that one side, right there. You can see in the cameras there's sort of a split there. Let me try the lens. Let's put the lens back on. See if you can see that any better. It's about the. It is kind of funny that the the filter of the camera, it takes out the infrared as I believe. It does change it somewhat. Yeah, so we'll do without the lens. All right, so let's play this out a little further.
Getting narrower. If I look here, oh, I'm not yet at the tenth of a millimeter. I'm getting there. Going slowly.
See, and I see lots of lines here, lots of pattern showing up.
Squeezing it. I'm squeezing those photons. Those photons now are forced to go through an extremely narrow opening.
Okay, now it's not narrow for a photon, so that's sort of a deceptive way to say it. What he's doing is filtering out more and more light. So less light is coming through, less and less light, and the amount of light that goes through that's close to the edge of a surface is increasing. So as the slit gets narrower, the odds of a photon traveling very close to the edge of the material increases.
And Heisenberg is very shortly going to jump in.
Alright, so Heisenberg's already jumped in. There's a bunch of lines here. They're pretty clear. I can see them on the camera also. Very clear. So this isn't exactly what's traditionally talked about in the 2-slit experiment with 1 slit open, 1 slit covered. This isn't exactly what they tell us we're supposed to be seeing. They don't tell us about this. They just say, oh, it just went back to being a blob. Well, it's not a blob. It's clearly got a lot of interference pattern in it. So he keeps mentioning Heisenberg. So yeah, he read a little bit earlier in the video. And apparently Heisenberg was quite comfortable. It's been left ambiguous in some of the conversations I've heard of whether he was arguing for the indeterminacy in terms of a mathematical problem or indeterminacy in an absolute. What the fuck was that? As an absolute problem. And I don't. Clearly, Heisenberg thought everything that it was an absolute problem. And what they're arguing here, what Walter Lewin is arguing, is that as the slit gets narrower, we know more specifically where these photons are going through the slit. And as we have more specific knowledge about their horizontal direction, they get less determined, which means somehow they wander more. Which doesn't really explain why they would wander more. Somehow they have to make us think they're not where they are. I mean, you can't change the fact that we do know more information about where they are, and them going somewhere different isn't going to change the fact that we have that knowledge, so I don't even see how those two things correlate. I think clearly the reason why we're seeing pattern is because the photons now, the amount of light getting through is, say, 1/4 of the amount of light that was getting through just a little while ago, and the amount of that light that is in close proximity to a slit is now also quadrupled.
And says you're going to pay a price for that. You know too well where those photons are in the x direction. The price you pay, that nature will now make the momentum.
So again, this doesn't look very much as just like a blob of light, again, as it's described in the traditional two-slit experiment. So this is the actual distance that the slits usually are, and this is what a single slit does. Okay, so this isn't a two-slit pattern, this is a single slit.
Undetermined in the x direction. And you begin to see it now.
It's getting wider and wider. So there's a good point just to illustrate that it's very similar to the two-slit pattern, except these second maximas are much weaker. So instead of being half as strong as this one, they're 1/4 as strong, and this one's 1/8 as strong, and 1/16 as strong. So as they go out, they get weaker and weaker. But they are, they do extend beyond what this image shows.
Widening, even photon.
Okay, so now everything's getting wider, so the proportions have remained the same. So all those little lines we saw before are essentially just becoming wider and wider and wider. So everything's just getting wider as the slit is made narrower. So that's something to keep in mind as an explanation. So essentially it's the same pattern that always existed, and now the pattern's being revealed because the spacing is getting wider and wider. So it's making it easier and easier to reveal these distinctions between the intensity. And still, on this camera image, this center looks substantially brighter than in the image I'm seeing. The image I'm seeing, it's just a green blob. There's very little, it's a little lighter here in the center, a little bit lighter, but it's very even. And in the camera, it's substantially different, which is interesting.
Here you see some dark lines, which I will not further discuss today, but notice.
Okay, so now he's spreading them out even further. So now it's just widening everything, proportionally wider.
Spreading. Of course, when I squeeze this slit, when I make it narrower, it's obvious that I lose light, because the light that hits the side of the slits is not going through.
Right, and how much is the camera compensating for that? So that might be part of the deception here, is now the background is much lighter. You might be able to see that. This background has now gotten substantially lighter than it was before, I believe. Now let's go back here. See, that's a substantially darker background. So you can see that the contrast on the camera has altered. Part of the perception of this image has been distorted by the fact that the camera is compensating for the contrast, and this background is going to keep getting lighter as this dot gets fades.
Getting narrower, getting narrower, getting narrower, but I'm nowhere nearly 1/10 of a millimeter yet. Getting clearly narrower. You see it's getting narrower, it's getting narrower. Now, if I look here, I'm not yet at the 1/10 of a millimeter. I'm getting there. Going slowly.
You can sort of see how the contrast. So there's real black. This is getting grayer and grayer.
Go through an extremely narrow opening. And Heisenberg is very shortly going to jump in and says you're going to pay a price for that. You know too well.
So this light is getting, this signal,
the price you pay.
This signal was actually getting weaker and weaker, which means the camera was increasing the opening wider and wider to take in more light, which meant that this background kept getting lighter and lighter. So it's a little deceptive.
Nature will now make the momentum undetermined in the x direction. And you begin to see it now. You already begin to see that the center portion is widening. Even photons appear here. You see some dark lines, which I will not further discussed today, but notice that the light is spreading. Of course, when I squeeze...
So at that maximum point of interest, of pattern, you could argue that's pretty far from what is traditionally described in the two-slit experiment as what happens when you close one of the slits. Clearly, the pattern doesn't disappear. It could change, but it shouldn't disappear. You shouldn't get this. Okay, so that's the deception. What you should be seeing when you have one slit open is, you know, one of these. Let's get to the. Where's the good one? There it is. Okay, this is what you should be seeing when one slit is covered, not just a blob. So anyway, and then, you know, then there's another thing to understand is, so, you know, this is with the light focused on the center of the closing slit. And so what happens when the two slits are slightly off the center? Well, they're right next to it, but they're off it still. That's going to change, you know, what kind of deflection or how much light is going to be available for this diffraction. So anyway, I guess that's, I don't want to, oh, it's not that I don't want to. I don't know if I have anything brilliant to add. Oh, that bulb burned out again. Son of a bitch. Anyway, so eventually I will, yeah, I'll add some more. I mean, the bulb bugs me. I cleaned it. They're old bulbs, so I guess that's what they're going to do. But that's what they do, you know, almost trips the circuit. You know, they burn out. The filament must fall in the metal and it shorts. Anyway, so yeah, so this is, you know, I still got to do some more thinking. I got to play around some more. So I am thinking of setting up like a two-slit experiment using two laser beams and shooting one off its center. So have two beams that are off their centers and see what happens with the light and see what kind of pattern you create when you're using when you're not using the brightest light but the fringe light, just to see if it has more of an effect. So anyway, but I think this is, you know, this needs a little more explanation than making up some crap about it. The photon is interfering with itself. Clearly, if these were shot as individual photons instead of a beam, would the argument be that the individual photons still would interfere with themselves? I mean, you would assume you'd get the same pattern if individual photons were shot through that single slit, right? Theoretically. So I mean, what are they interfering with? How can it be interfering with itself? Come on, that's really stretching it, isn't it? I mean, when there's only one wave, one slit. What's the other explanation for this? Besides what it is, which is some sort of diffraction that doesn't have anything to do with photons going through two slits at once. So anyway, until next time. Such.